You know about that famous essay that Eugene Wigner wrote. It was called The Unreasonable Effectiveness of Mathematics in Physics. Why do you think mathematics is so fundamental to physics, and why is it unreasonable? Why did Wigner use the word unreasonably effective?
For a long time, I actually thought, and I still believe part of it, that we reside in a physical universe. And the things that we think of are all actually physical processes by which we think. And therefore, the mathematics that we develop, the kind of mathematics that we developed, is perhaps constrained by that because we are physical entities. Maybe that could be one reason that almost everything that we have developed in mathematics have had impact on physics. But the other side of it is now also coming into perspective that physics have had remarkable influence on mathematics in the last 20 years as well. And there are whole areas of mathematics which have been opened up because of physics. One particular example, one well-known example, are the Gromov-Witten theory, which was developed by a physicist and later on taken by a mathematician and put on rigorous mathematical footing.
Yes, it lies at the very highest reaches of mathematics and physics today. But not all mathematics is fruitful. Not all of it gives you something that is useful. Only particular strains have actually led to some new prediction. Wouldn't you agree with that?
That is true, but as we, for example, in the 1930s or 40s, people were mathematicians were trying to understand gauge theories, abstract, just no relation with physics. But later on we found out that they were related to physics. And similarly, with other things which in most recent years, which mathematicians have developed independently, but we have seen that it has a relationship with physics, at least the kind of physics that appears in string theory.
In principle, mathematics could exist even if there was no physical universe. I mean, you don't need particles, you don't need objects, you don't need geometric figures or whatever. Just the power of pure thought is enough to create all mathematics, right?
That is true, but again, then we are going back to the question that can pure thought exist without a physical entity? I don't know. These are philosophical questions, I think, which are very difficult to answer.
Tell me, what sort of books do you read?
Every few years it changes. I was very much into, when I was younger, into books which are popular science books. But in recent years, I've gone away from that, and I enjoy more technical books which are popular but technical. For example, this book by Prime Obsession, which is highly technical but at the same time is a popular book on Riemann hypothesis. So I enjoyed it thoroughly. More recently, there's a book by a Berkeley mathematician, Frankel, Love in Mathematics, and it's highly enjoyable.
Yes, I've heard great things about it, but I haven't read it myself.